unit impulse response of a unity feedback system is given by C of t equal to solution. So what is given? C of t is given. What is C of t? C of t equal to t into e power minus t. C of t equal to t into e power minus t. Okay. So C of t is nothing but C of t is, if you take apply Laplace transfer function, C of s equal to, so t, what is the Laplace transfer function? T into e power minus t. If you shift, apply shift theorem, e power minus t actually come from s plus 1. Okay. So this is a shifting theorem. So 1 by s plus 1. So t, what is Laplace transform of t? 1 by s square. So C of s, if you take Laplace transform of this, taking Laplace transform, we get 1 by s plus 1 the whole square. Okay, 1 by s plus 1 the whole square. So this is the closed loop transfer function. So transfer function of the impulse response. So this is 1 by s plus 1 whole square. So you know that the closed loop transfer function and the open loop transfer function. So what is closed loop transfer function? Closed loop transfer function equal to g of s, open loop transfer function, divided by 1 plus g of s into h of s. Since it is a unity feedback control system, this is h of s equal to 1. H of s equal to 1. So simply t of s equal to g of s divided by 1 plus g of s. So what we have to find? We have to find the open loop transfer function of the system. So g of s we have to find. So if you modify this equation, so cross multiply this, so t of s plus t of s into g of s equal to g of s. So if you take g of s to one side, so if you take a common term, so g of s equal to t of s divided by 1 minus t of s. You will be getting this answer. So we are getting t of s here. So what is t of s? T of s is c of s, right? Both are same. Closed loop transfer function. C of s equal to 1 by s plus 1 whole square. So what is g of s? Instead of t of s, substitute 1 by s plus 1 the whole square. So g of s equal to what is here? T of s 1 by s plus 1 the whole square divided by 1 minus 1 by s plus 1 the whole square, right? You take LCM for this, what do you get? This cancel. 1 by s plus 1 the whole square minus 1. So g of s equal to s plus 1 whole square minus 1. So s square plus 2s plus 1, s square plus 2s plus 1 minus 1. So the answer is 1 by s square plus 2s. So this is the open loop transfer function for this system. Next is the input-output relationship of the system is given by d square y of t by dt square equal to x of t minus 2 d square x of t by dt square. The transfer function of the system is, we have to find the transfer function. So we have the dynamic relation here. What we have to do? Just apply Laplace transfer function. Okay, the solution is solution. Okay, so apply Laplace transfer function for the system, for the equation. So So what do you get? S square, keeping the initial condition 0, s square y of s plus, sorry, okay, s square, sorry, equal to t minus 2, okay, t minus 2 is s minus 2, right? X of t minus 2 is s minus 2, x of s, s power minus 2. So by applying Laplace transfer function for this equation, s square y of s equal to x of s into e power minus 2 2s, e power minus 2s plus s square x of s. So bring a y of s to one side. So y of s by x of s equal to e power minus 2s plus s square divided by s square. This s square comes in the denominator. So what do you get? 1 plus this s square cancel, 1 plus e power minus 2s by s square, s by s square, right? So this is the transfer function model for the equation. So next is what is the sensitivity effect? What is the effect on sensitivity of the system? Okay, the sensitivity of the system plays vital role in the closed loop path. Okay, closed loop path. In general, good control. Okay, good control system should be interactive. It should not be insensitive to parameter variations. Okay, but sensitive to whatever the command, input command given by the operator, right? So the sensitivity in the open loop should respond 100%. So sensitivity of the open loop, sensitivity of open loop system, open loop transfer function. Okay, what is open loop transfer function? Say G, input is R, so output is C. Here, so the overall transfer function is M. M equal to C by R. M equal to C by R. This is the gain value. Actually, the sensitivity of M with respect to two variations, two parameter variations. If there is no feedback, no variation at all. So only it vary the sensitivity of the system affected by the system transfer function. So definitely this will be dou M by M, dou G by, this is the per unit sensitivity, dou G by G. This become dou M by M, sorry, dou M by dou G of G by M, G by M. So mostly the sensitivity of open loop transfer function gives 100%. Okay, 100% variations. The sensitivity of the closed loop system. Okay, whereas sensitivity of closed loop transfer function. In closed loop, we can have two variations. See, one is G, forward loop, open loop transfer function, or okay. Sorry. One is the forward. The system may be sensitive to open loop transfer function variation, this gain, or the feedback gain. So there are two parameters variation in the closed loop system, R and C. So what are the sensitivity of closed loop transfer function with respect to the M overall transfer function. So the closed loop transfer function with respect to M. Okay, consider G varies. G is a parameter that may vary the sensitivity of the gain of the overall system transfer function M. Okay, to the variation of G. First, the sensitivity of M, sensitivity of that is sensitivity of M with respect to G in the closed loop transfer function. This is nothing but percentage change in the overall gain. Percentage changes in M divided by percentage changes in the open loop transfer function G. Percentage changes in the G. Okay. So this is nothing but the dou M by M, dou G by G. So this is of 100%. Similarly, this also for 100%. So in the closed loop transfer function, the percentage changes in M also 100%. If the percentage changes in G also 100%, so the sensitivity is only 1% is the variation. Okay, so sensitivity of G with respect to M is G by M of dou by M is what is the closed loop transfer function? Dou G. This is G by 1 plus GH. Okay, 1 plus GH. So this is where dou M denotes the incremental change in M due to incremental change in G. Okay, so this dou M is the incremental. Say, suppose an amplifier gain is say 1000. Suppose the plus or minus 20. This means this is the limiting value. So dou M is denotes the incremental change in the M. Similarly, dou M is incremental changes in M. This is dou G. Dou G is say incremental changes in G, right? So if you differentiate this equation, we will be getting G by M. So again, M is nothing but what is the M? The overall transfer function. Okay, so G by M of, if you differentiate this, you will be getting finally if you substitute this, differentiate this, say you can also do no problem. 1 plus GH whole square of 1 plus GH being H constant here. There is no change in H. So 1 plus GH into numerator with respect to G1 minus numerator into differential of the denominator with respect to G. So 1 plus H, right? 0 plus only H, GH, right? So G by, what is M? Again, M is G by 1 plus GH into, if you multiply this, 1 plus GH minus GH. So this cancel. Remaining is 1 plus GH whole square. So if you bring this D cancel, this go to the numerator, this and this cancel. what we get? So we simply get only 1 by 1 plus GH. So this is the sensitivity variation of M, the overall system transfer function M with respect to G. So sensitivity of M with respect to G equal to 1 by 1 plus GH. That's why this feedback, the changes in G and M will not affect much. Okay. So this relation shows that the sensitivity function can be made arbitrarily small by increasing GH value. Okay, so the sensitivity function can be relatively small. So if by increasing this value, okay, if you increase this value, so the what happened? The sensitivity decreases. Okay, sensitivity decreases, provided that the system remains stable. We should, if while altering the GH, the constant, we should not disturb the system stability. Okay, in open loop system, the gain of the system will respond to one-to-one system because input and output directly proportional. So the gain of the system respond to one-to-one, whereas in general, sensitivity of the system gain, okay, of a feedback system is to parameter variations depends on where the parameter is located. So this is the system concept. So next is sensitivity of the M with respect to changes in the loop, feedback loop. Okay, let's see the sensitivity of closed loop transfer function. Closed loop transfer function gain M with respect to H, changes in H, sensitivity with respect to H. So what is M? M is again, you know that closed loop transfer function gain. So the closed loop transfer function gain, this is nothing but G by 1 plus GH, right? 1 plus GH. So what is the sensitivity of uh, M with respect to H? So dou M by dou M, the incremental change in overall gain divided by percentage incremental change in the H, dou H by H, dou H by H. So this is equal to dou M by dou H. So incremental changes in the M overall gain and the incremental changes in H. So into H by M, H by M. So keeping H by M similar to the previous steps, H by M, dou by dou H of, what is M? We know G by 1 plus GH. If you differentiate this, so what you will get? H by M, denominator square, 1 plus GH whole square, 1 plus GH into, with respect to H, 0. There is no H term in the numerator, 0. Minus the numerator term into differential of denominator. So what do you get? We have only G, another G, right? G, this H. So keeping numerator, denominator. All right. G square. The 0. Okay. Denominator square. Denominator into numerator differential with respect to this. So we'll be having partial, no, the keeping G constant. So that's 0, right? uh, minus h by m of minus g square divided by 1 plus gh is the whole square. Here you can simplify. H is there. What is m again? G by 1 plus gh into minus g square 1 plus gh the whole square. Right? So this square, this term cancel, this g cancel. So h, only h is there. So h by g. So this h is in the numerator. So what we get? We are getting minus gh divided by 1 plus gh. So the sensitivity of overall gain with respect to the feedback feedback gain changes. What we are getting here? Minus of gh. The minus sign indicates that when h increases, this minus sign indicates that when h increases, m decreases and vice versa. If h decreases, m increases. This vice versa. So always saying that sensitivity of the overall gain with respect to the feedback gain will be the modulus, keeping the modulus. So sensitivity of m with respect to h always more than that of sensitivity of m respect to the forward element, forward gain. Okay, therefore the output is more sensitive to feedback path parameter changes than the feed forward path gain. Okay, so this is the important concept in the feedback, effect of feedback, concept. Okay, next we see in a control system. In a control system shown in figure below, if g of s changes 10%, respective changes C1 and C2 are. C1, C2 are means C1 is in the open loop. This is in C2 is in closed loop. So when G solution, okay, solution when G changes by 10%, G changes by 10%, the per unit change, percentage change in that is dou G by G equal to into 100. Okay, percentage is 100, right? Equal to 10%. So C1 equal to 10%. C1 is 10%. That is in open loop. Okay, whose sensitivity is 100%. Okay, this is the case 1. Okay, next is C2. So when percentage change G change 10% in the closed loop. What is percentage change in M divided by percentage change in G equal to 1 by 1 plus GH. So just before only discuss. So if you substitute 1 by 1 plus 10% here, keeping a unity feedback, say unity feedback control system, say since keeping h equal to 1, so 1, so what I get, we are getting 1 by 11, 1 by 11, it's almost equal to 1%. Okay, so the percentage change in sorry in C2, percentage change in C2 equal to 1% only, whereas percentage change in C1 is 10%. That is sensitivity is 100% change. So next, the next problem is consider the following system shown in figure. RFS is reference input, CFS is the output. So here M equal to C by R. So the forward gain is G, feedback H. So determine the sensitivity of M with respect to changes in K. Here one additional gain K is added with this loop. So additional. So what happened to the sensitivity changes M with respect to K and H of S? Okay. So for that, what is C by R equal to M? This is equal to, so what is the closed loop transfer function? This is G by GH. Okay. So G by 1 plus GH. So the closed loop transfer function of this loop is G by 1 plus GH. The K is in series with this, so multiply by K. So KG divided by 1 plus GH, right? So this is the overall closed loop transfer function of the system. Now, what is sensitivity of M with respect to K? With respect to K, as usual, dou M by M divided by dou M by K. Sorry, dou K by K. That is K by M of dou by dou K of M is Kg divided by 1 plus GH. Understand? Very good. So if you differentiate this, substitute, you will be getting 1. You will be getting 1. So that is since K is not in the loop, K is not in the loop, sensitivity is equal to 100%. Okay, sensitivity is 100%. Next is next condition, when what happened to the M when it is with respect to H of S. So what is the second case B? So sensitivity of M with respect to H equal to dou M by M divided by dou H by H, which is equal to, so what do you get? Dou M by, so keep H by M outside, H by M as constant, dou M by dou H equal to H by M dou of, what is the closed loop transfer function? Kg divided by 1 plus GH, right? Dou H. So if you differentiate this, you will be getting minus GH dou M by dou H. So minus GH divided by 1 plus GH. The same value you will be getting. Clear? Same value you will be getting. So this is the changes in the sensitivity changes of you do the brief differentiation. So differentiate this, you will be getting this answer. Okay, by H equal to minus GH divided by 1 plus GH. So what is the next problem? An amplifier with the open loop voltage gain A. An amplifier with the open loop voltage gain A equal to 2000 plus or minus 100 is available. Okay, is available. It is subjected to have an amplifier whose voltage varies by not more than 0.5 percentage. Okay, 0.5 percentage. Whose output voltage, the amplifier, not more than plus or minus 0.5%. The value of the feedback factor required is equal to, there will be 4 choices. So we have to find the correct factor value. Okay. So solution is very simple. Solution. First we see what are the parameters given. Okay. So the G, open loop gain, G value is given in the feedback. So this is also a feedback system. So open loop feedback, G, we have to find H factor value. So plus, minus, C or K. So we have to find what is H. So G value is given. What is G value? 2000 plus or minus 100. So what is G equal to 2000 open loop gain? This is the open loop gain. What is plus or minus 100? Dou G. Dou G equal to 100, right? So percentage change in G is, so percentage change in G, that is dou G by G into 100. What is the percentage change in G? That is 5%. So the open loop has is available. It is subjected to so dou G by G is into 100 equal to, dou G is 100 divided by 100 divided by 2000, right? No problem. So dou G by G equal to 5% into 5%, right? To 5%. So 100 dou G by G is yes, that's it. Sorry, 100 by 2000 into 100. So 20 cancel. So 20 by 100 by 20, 5%, exactly, right? So then percentage change in M, percentage change in M is the overall gain. So the overall amplifier whose voltage varies not more than 0.5. So percentage change in M is 0.5%. Percentage change in M is 0.5%. So percentage change in M divided by percentage change in G equal to 1 by 1 plus GH. Okay, this is equal to 0.5 divided by 5. Okay, 0.5 percentage change in m is 0.5 percentage divided by 5 percentage. What is, how do you get, how much you get? So 0.5 divided by 5, which is equal to, so cross multiply this, you substitute g value. What is g value? G value is 2000. G value is 2000. Right? See here, 1 by 0.5 by 5. 0.5 divided by 5 equal to 1 by 1 plus 2000 h. 2000 h. Cross multiply 0.5 equal to 0.5 is 1 by 2. So 1 by 2 into 2000 h. Okay. 0.5 plus equal to 5. So 0.5, this 2 cancel, 1000 h, 1000 h. If you bring that to that side, 1000 h equal to 5 minus 0.5, which is equal to 4.5. So h equal to 4.5 into 10 to the power minus 3. So this is the correct answer. So very important question. Next is, if R of t has unit degree Celsius and C of t has units in millimeter, that is okay, millimeter, the units of K, what is the unit of this K? Okay, they are asking is C of t, this is degree Celsius, R of t is millimeter. What is the unit for gain? Okay, answer is very simple. So degree Celsius by millimeter. So this K is a open loop gain. Okay, gain, open loop gain. Next question is, for a linear time invariant system described by the mathematical equation 2d square y of t divided by dt square, sorry, 2d square y of t by dt square plus 3 dy of t by dt plus 4 y of t equal to r of t plus 2 r of t to r of t minus 1 with 0 initial conditions. What will be the transfer function? What will be the transfer function? What is where you can easily tell? Solution. Okay. What is solution? Apply. Apply. So the time domain equation is given. To get the transfer function model, we require Laplace domain. So equation in Laplace domain. Apply Laplace transfer function for the equation, for the time domain equation. Time domain equation. So what you get? Keeping initial condition 0, 2s square y of s plus 3s y of s plus 4 y of s equal to r of s plus 2 s power minus 1. Okay, sorry, e power minus 1s, e power minus 1s into r of s. So taking a Laplace transform of t minus 1 is e power minus s, e power minus s. So if you take y of s as a common term, you will be getting 2s square plus 3s plus 4 equal to, taking r of s common term, okay, 1 plus 2 e power minus s. So what is the transfer function model? Y of s. Transfer function is Laplace transform of the output to Laplace transform of input R of S equal to 1 plus 2 e power minus s divided by 2s square plus 3s plus 4. Am I right? So what is the next question? In the negative feedback control system, shown below, determine the time constant of the closed loop transfer function, closed loop system. Okay, so negative feedback control system. So feedback is negative. So for this, this is the open loop G, this is H. What is the question is, determine the time constant of the closed loop system. So what is closed loop system? C of S by R of S. So M equal to C by R. C of S by R of S equal to G by 1 plus GH for negative feedback. Right? Substitute here A by 1 plus S tau divided by 1 plus A by 1 plus S tau into beta. What we are getting? The A is the numerator. The denominator, this cancel together, cancel. 1 plus S tau plus A beta. See, A beta are all constant. So only in the denominator is one also constant. So M equal to A by 1 plus A beta. This is constant. Okay, plus S tau. Okay, what is the standard first order transfer function? So the first order transfer function is equal to K by 1 plus S tau. So we should bring this denominator to this format. So how to bring this? Divider, the whole equation divided by 1 plus A beta. So this equation becomes A by 1 plus A beta divided by 1 plus tau by 1 plus A beta into S. This is the closed loop system similar to this. So what is K? The gain of the first order system is K equal to A by 1 plus A beta. Sometimes the same question will be asked. What will be the gain? The static gain of the first order system in closed loop. So this may be the another choice. So A by 1 plus A beta also will be asked. So when compared with the denominator, the coefficient of S term is the time constant of the closed loop system. What is the time constant? So the closed loop time constant equal to tau by 1 plus A beta. So tau by 1 plus A beta. This is the closed loop time constant. Understand? Next question is, if the open loop transfer function of negative feedback control system is say solution is, so G of S is given. So what is G of S? K by 1 plus S whole cube. Then what will be the gain? We have to determine the gain K of a closed loop pole at the closed loop pole is given. Okay, closed loop pole is given. So the open loop transfer function is given as K by 1 plus S. So what is the closed loop pole? So closed loop pole M equal to C by R equal to G by GH. So this is negative feedback unity transfer function. So h of s is 1 plus k by s plus 1 the whole cube divided by 1 plus 1 by k by s plus 1 the whole square, whole cube. So what is that? S plus 1 the whole cube, this denominator cancel. So numerator k s plus 1 the whole cube plus k. Okay, this is m. So this is the closed loop transfer function. Okay, so the pole value is given. So pole at s equal to minus 1 by 2 plus or minus plus j root 3 by 2. Root 3 by 2. Let us substitute this value in the characteristic equation. So the denominator part of the m. So the denominator part of closed loop transfer function equal to 0. So this is equal to characteristic equation, right? So s plus 1 whole cube plus k equal to 0. Okay, so now we can substitute s plus, instead of s we can substitute minus 1 by 2 plus j root 3 by 2, right? Root 3 by 2 whole cube plus 1 whole cube. This is yes, right? Yes, plus 1 whole cube plus 1 whole cube plus k equal to 0. So if you expand this, actually minus of plus 1 is plus 1 minus of is 1. Sorry, plus of, right? Plus of. So plus of plus j root 3 by 2, right? Whole cube plus k equal to 0. Understand? So you use, you know that a plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. So use this relation here. So what do you get? Here half cube. So a cube. So a is half cube plus minus a cube plus 3a square 1 by 2 square j root 3 by 2 plus 3 half into j root 3 by 2 whole square plus j root 3 by 2 whole cube plus k equal to 0. Say if you what is this 1 by 2 whole cube 1 by 8 plus say j is there, j is here, j 3 by 4 into root 3 by 2. So 3 by root 3 by 2 plus Say here square j is here. Directly we can put j square is -1. So here put -1 minus sign here. So 3 by 2 square 3. Root 3 is 3. Denominator becomes 4 plus minus j. Again minus j. Root 3, 3 root 3. 3 root 3 by 8 plus k equal to 0. So everything denominator is 8. So 1 plus, so real term you can add, we can add 1 plus 1 minus 9 by 8. 9 by 8. So 1 by 8 minus 9 by 8. These two terms over. Okay. So j 3 root 3 here plus 3 root 3 j root 3 minus j root 3. Think plus j root 3 by 3 root 3 by 8 minus 3. So these two cancel each other. Plus k equal to 0. So what do you get? So taking LCM here. So 8 minus 8 plus k equal to 0. So minus 1 plus k equal to 0. So k equal to 1. So the answer for this, sorry, k equal to 1. So this is the required gain for the pole at S equal to